Hello, everyone, and welcome to the October 2025 edition of the Azure Database for MySQL webinar. I'm Saurabh Kirtani, and I'll be your host for today. I'm a senior product manager in Microsoft Azure, and today we'll walk you through some of our features and share the latest updates that make managing MySQL on Azure simpler and more resilient than ever. First up, we'll have Vandhana, who's going to be talking about simplifying disaster recovery, and she'll be talking about fundamentals and new enhancements in backup and restore. And next, we'll have Elendil coming in to speak about various topics to enhance MySQL management, such as in-place upgrade, near-zero downtime maintenance, and custom port support. And with that, I'll hand it over to Vandhana, who's going to be speaking about backup and restore concepts. Hi, Vandhana.
Thank you.
Welcome to the webinar.
Thank you, Saurabh. Hello, everyone, and thank you for joining. I'm Vandhana Mehta, and I'm a product manager in Azure MySQL team. And today I'm excited to walk you through the fundamentals of backup and restore and then share what's new in this segment. I'll first cover foundational concepts for backup and restore in Azure MySQL. Then we'll straight away zoom into the details of recent enhancements in the product. So first, maybe let's understand what's backup, right? So in simplest term, a backup is a copy or a snapshot of your data taken at a point in time so that you can recover from disaster scenarios like accidental deletes, data corruption, and even ransomware attack. And in MySQL specifically, we support two types of backups. First is automated backups. These are system managed backups. These are full snapshot backups taken by the system once daily, along with transaction logs, which is also the binary logs, which are backed up every 5 minutes. The second variation is on-demand backup, and as the name suggests, these backups are triggered on demand by the end user, giving them the better control over how they want to manage the backups. Now, both these backups are governed by certain characteristics. So the first characteristic is actually the backup cost. And it is important to note that in terms of backup cost, Azure MySQL offers free backup storage up to 100% of provisioned server storage. Let me explain this by an example. So if you provision a server with 50 GB of storage, then 50 GB of backup storage is offered to you free of cost. The second is retention. Now, both the backups are governed by retention period between 1 to 35 days, which means when you configure a server, you can specify the retention period to be between 1 day to 35 days. Third aspect is the redundancy. So backups can have three types of redundancy, which helps determine how backups are stored and what is the degree of resiliency that you can choose from. We will discuss more about redundancy in the subsequent slide. So let's look at the redundancy option that we have in Azure MySQL. What is redundancy? Simply put, it defines how and where your backups are stored to keep them safe. Now, there are three types of redundancy that you can choose from. First is locally redundant storage. It's also known as LRS. This means that your backup is stored within a single data center in the same region. Now, this is the most cost-effective resiliency option, and it is great for scenario where regional redundancy isn't a strict requirement and you just want a way to get past any kind of DR scenario. The second is zone redundant storage or ZRS backup. Now here your backup data is automatically replicated across multiple availability zones within the same region. When I say multiple availability zone, it implies it can be copied across multiple data centers within the same region. So the advantage, when one zone goes down, your backup is still safe and accessible from another zone and you can get your server backup. The final option in terms of redundancy is geo-redundant storage, also known as GRS. Now, this one gives you the highest level of protection. So your backup is actually copied into a secondary region that's hundreds of miles away from the primary region. So if there is a regional disaster or an outage, you can still restore your database using geo-replicated copies of the backup. So if I have to summarize, LRS actually keeps your data safe locally. ZRS protects you within the region, and GRS, which is the highest level of resiliency that we offer, protects you across the region. So with that, let's look at different restore options we have in Azure Database for MySQL. So broadly here we have two main categories of restore. One is point-in-time restore, another is geo-restore. Point-in-time restore is also called as PITR, P-I-T-R. Now starting with point-in-time restore, PITR, this option is the one that you will use most often. So it will let you restore your server to any specific moment within your backup retention window. So within point-in-time restore, there are three variations that you can leverage to meet your recovery objective. First is the latest restore point. As the name suggests, this brings your database back to the most recent possible moment using the latest available binary logs and latest available snapshot. It's ideal for recovering from unexpected outages. The second is a custom restore point. As the name suggests, here you can pick up the exact timestamp. For example, you can say 2:37 p.m. yesterday, right before the incident occurred. Now, this gives you the precise control over how much data you want to roll back to. The third one is actually fastest restore point. Now, this option optimizes for recovery time. So instead of applying all the binary logs or having to replay all the binary logs, it restores to the nearest available full backup. So it's useful when the recovery matters most to you and you need a faster restore option. So you're going to pick up faster restore point. The second category of restore option that we offer is geo-restore, which comes into play during regional outages. So geo-restore, as I earlier mentioned, it makes use of the geo-redundant backups, which offers highest level of resiliency, which means it copies your data stored in one Azure region to another secondary Azure region. Now here you can have two options. Either you can choose to use this backup to restore to a geo-paired region, or if you are strict on data residency requirements, you can also choose these backups to restore to any Azure supported region. So that's the flexibility you will have when you basically pick up GRS as your resiliency backup option. So if I have to summarize, point-in-time restore, also known as PITR, is what you rely on for your day-to-day operational recovery, while geo-restore is your safety net for region-wide outages. So together, these options will ensure your data is both recoverable and resilient. Moving on. So over the past few months, we have been actively skimming our feedback channels, and we have been hearing a lot of feedback on restore performance, flexibility, and backup cost as well. And many of you have asked questions over multiple channels that how can we restore faster? How can we optimize the backup storage cost? Can on-demand backup be triggered programmatically? So keeping or maybe reviewing all this feedback, I'm quite happy to share that several of these areas have made significant progress. So in this specific section, I will walk you through some of the recent enhancements that we've made in the backup restore capability within the service, aligning to the feedback that we have received. So let's talk about the first one, which is basically taken up to ensure we give you a better restore speed. So it is ability to configure backup interval for your automated backups. Now I'll take an example. Imagine you are running a busy online store, which thousands of transactions every hour. Now one day something goes wrong and you need to restore your database to an earlier point in time using PITR or point in time recovery. Now if that restore point that you've chosen is say 18 hours away, then of course the way system will work is that it will have to replay a lot of transaction logs to get you there. Now, that's what makes the restore time longer, especially if the server is running high transaction workloads. Now, this is where the enhancement comes into picture and becomes very handy. So here's what we have done. We have added an option to take automatic backups more frequently. So instead of just one snapshot every 24 hours, you can now choose to take them more often, maybe every few hours or depending on certain intervals based on how active your application is. As a result, what you get is a faster restore time. So simple change, big impact. We'll of course cover this more in a demo, but I'll go through the next set of enhancement that we have taken up recently. The second one is enable auto scale of IOPS during restore. Now, here's another small but really powerful feature. It's also tagged as Fast Restore. If you look in the Azure portal, it's called Fast Restore. This feature allows you to enable autoscale of IOPS for both source and target server at this time of restore workflow. What that means is that Azure will automatically boost your storage performance temporarily while restore is happening. So this extra burst of IOPS will help speed up the entire restore progress, and which is especially useful for large databases or busy workloads. And once the restore is completed, you will have a choice to turn off this feature to optimize your cost associated with this setting. So it adds to the flexibility and also gives you an option to improve your restore performance. The third is a very simple enhancement. It's ability to delete the on-demand backup. While you can trigger an on-demand backup, you'll also have the ability to delete it to optimize the storage cost associated with extra snapshot backups and retain only those that are needed by you or your BIOS system. The fourth one is an interesting one. It's about automatic scheduling of on-demand backup. So you can now use automation task to schedule triggering of on-demand backups at a predefined frequency. Now, this automation task is built in Azure portal as a option that you can leverage. It is powered by Azure Logic Apps under the hood, and it provides a very lightweight option to create an automation for triggering on-demand backup. And we will show you how to do that in a demo to follow. So let's dive straight into the demo. So this is the Azure portal. You have to navigate to Compute and Storage Blade. Here I'm going to show you how you will configure the backup interval. So this is the option that you'll see, backup interval in hours. So the default value is always 24 hours, but you can choose to update it to 12 hours or 6 hours based on the application needs. Here, let's save to 12 hours. So once saved, deployment gets completed, and let's quickly check if the configuration was saved. We go back again to Compute and Storage Blade and look at our backup interval. So it's set to 24 hours, which means backups will be taken every 12 hours. Now, going to Backup and Restore Blade, I wanted to call out the delete feature here. Here you see some of the on-demand backups listed. Now you see a delete option here. You can click on the delete option and it will delete the on-demand backup that is available to you. Next, let's look at the automation task, which will help you basically automate the triggering of on-demand backup, allowing you to not take it manually. So here you have to just select the pre-available template and make all the connection authorization, filling the required details for the task name, backup time, a date and time that you can specify here. Then you can pick up the time zone based on your requirement and specify an interval, say 2, and specify a frequency at which you want the backup to be triggered. You can switch on the notification and the notification will be sent on the entered email. I see that we have to input the backup time, which we did not. Okay, let's fill that in and click on review and create. So this creates a simple lightweight automation task. And once task is created, you will see the task listed here. It's scheduled for the defined time. And when you click on view, whenever the task runs, you'll be able to see the run details right here. I already created an automation task, which basically triggered an on-demand backup as per a predefined schedule. I'll quickly show that. So in backup and restore blade, you see this one. This is a on-demand backup, which was triggered by an automation task. Now that brings us to the end of the demo. Over to you, Saurabh. Thank you.
Thank you, Vandhana. Thank you, Vandhana. It was a great session to talk about backup and restore, and it's great to see the new updates that have come in over the past few months. Let's move on. Next up, we will be having Elendil, who's going to be talking about enhancing MySQL management. And there are a number of feature updates that we have released over the past month. And Elendil is going to be talking about custom port support, near-zero-downtime maintenance, and in-place upgrades. Elendil, welcome to the webinar.
Hi,
if you can just share an introduction about yourself. Please go.
Okay, cool. Yeah. Hi, everyone. My name is Elendil. So I'm the Senior Program Manager in Azure MySQL team. And I'm mainly focusing on our network and the maintenance and major version upgrade part. Today, I'm going to share some of our latest feature, which you can see in the slides that we're going to support customer port and the near-zero-downtime maintenance, which has been in public preview for quite a long time. And now we are announcing GA for it. And last, we are going to announce the in-place upgrades for the 8.2, 8.4 versions GA, which is also a very, lot of customer feedback from the communities. Yeah, let's go to the details of this feature. Okay, so first is the customer port. So as you can see here, we have some customers who maybe because of their security requirement, maybe because of they have some legacy applications, they need to build their Azure MySQL database in non-default port. So we hear this feedback, and now we are launching it as a GA feature in our Azure MySQL. Not like our public preview versions. Currently, we support not only the VNet injection servers for the customer port, we also going start support public network and private link network for our customer port, the support. So the port range is from the 25001 to 26000. And we do not only we support the different network options, we also will also cross support our existing features like HA and the replica server creation and the Peter to different custom port. And please note that for our current custom port support versions, we only support creating a server with custom port when the server is in creation. If the server is already created, you are not allowed to change the port. And also geo restore and geo replica creation with custom port are not supported. Next slide. Okay. So this is the in-place upgrade from MySQL 8 to 8.4 GA. So as we all know that Oracle are going to deprecate the MySQL 8 in next year, and the MySQL 5.7 is already deprecated, and both these two versions will enter into our extended support model in next year. So I believe a lot of our customers would like to upgrade to the latest LTS version, which is 8.4. So Azure MySQL currently announced the GA version of 8.4 versions, and we are going to currently support this in-place upgrade from 8 to 8.4, which can make our customers have a very seamless experience in the upgrading of Azure MySQL. And we can go to the next slide. Next is also it's heavily used features by our HA-enabled customers. So previously, our near-zero-downtime maintenance public preview, it will relying on a DNS-based HA infrastructure, which means that during the maintenance, that when we triggered a maintenance, also we call it the planned failover during the maintenance, we will add sometimes 30 seconds DNS refresh time to our overall downtimes. So from the application side, when we are having the maintenance, even you have HA enabled, your downtime maybe will be like more than 40 seconds. In some worst case, for example, your DNS refresh time is in a set up to like 10 minutes or even higher. Even if you have HA enabled for your server, the maintenance downtime is still high because of this DNS refresh time. So in our near-zero-downtime maintenance, we have totally switched our DNS-based HA infrastructure to the something we call a dedicated SLB infrastructure, which means that all the failover and happened inside our Azure MySQL part. So you don't need to have this DNS refresh times. Just please note that for our existing servers, there will be some migrations so that you can migrate the existing HA infrastructure to our dedicated SLB-based HA infrastructure. So by leveraging this new infrastructure, we totally removed this 30 seconds DNS refresh time. So what we experienced inside Azure MySQL HA failover during the maintenance will be the time that your application experienced during the maintenance. So usually you will just have like 10 seconds maintenance downtime for every maintenance. Okay, let's get deep dive into the demo session.
In the Azure portal, go to Create MySQL Server and choose MySQL version 8. Select your regions that you want to build your Azure MySQL Flexible Server and specify your server name. Set up your administrator login and password. Then go to the network settings. As you can see here, we currently support both public access and private access for the customer database port. And we can change the database port from 25000 to 26000. So let's changing it to okay. And to simplify today's demo, I've configured the server to allow access from all IPs in the network tab. And please do not do this in production environment and always restrict access to a trusted IP address for security. Okay, we are all set for the customer port setup. So let's create this server by clicking the review and create. Okay, let's create. Okay, the deployment has finished. So let's go to our newly created server to take a look at the server port information. Go to the connect tab. So as you can see here, the port is now in the 25001. And we can copy this connection strings to our terminal to try connect to our new server based on the new port. Open our terminal and paste the connection string. As you can see here, now we can connect to this new Azure MySQL through the non-default port 25001. And let's run a select version command. Okay, so everything works fine. With our server up and running on a custom port, let's move on upgrading it to MySQL 8.4 without any data migration. In-place upgrade allows you to move from MySQL 8 to 8.4 without migrating data, changing server identity, or reconfiguring your environment. It's fast, safe, and fully managed. Let's directly go to the portal and click the upgrade button to perform a in-place upgrade. Just a soft reminder that the validation option for 8 to 8.4 is currently not supported, but you can still leverage the Oracle official tools to run the validate on your client side to perform a pre-upgrade validation before you perform the in-place upgrade. Check the confirm I have completed these steps, and let's start the upgrade. All right, the upgrade has completed. Let's go back and see how it works. As you can see here now, the MySQL version in our overview page is 8.4. Let's verify it in our MySQL CRI. Let's reconnect to this server. Select version. Okay, you can see here it is now 8.4.5. Please note that the major version upgrade will take a period of time based on the data object you have in the database. So it is better to have some validations before you perform the major version upgrade. And if you want to have the minimum downtime major version upgrade, you can try create a replica or PITR one of your current existing 8.0 version server and perform the major version upgrade on that replica server or the restored server, then change your connection strings to the new upgraded server. Azure MySQL now supports near-zero downtime maintenance for servers with high availability enabled. If a server was created without HA, you can enable it later through the portal. Please note that enable HA after creation may cause downtime, so we recommend doing this outside of your business peak hours. With GA of the near-zero downtime maintenance for non-HA server, we've introduced the dedicated SLB for HA servers. Compared to the previous version, the failover logic has been significantly optimized. So maintenance now triggers automatic HA failover, and the new SLB mechanism eliminates the need for client-side DNS cache refresh, and it will dramatically reduce the precise downtime during maintenance. Because we have already created a server with HA enabled, so we don't need to do anything here to enable the near-zero downtime maintenance for an HA server. If you created your server, without HA, just enable it in the HA tab in your Azure MySQL portal page. Okay, to summarize, we created a Azure MySQL 8 server on a customer port, and we validated and performed the in-place upgrade to 8.4. And we enabled this, we by default enabled the HA for this server to unblock near-zero downtime maintenance. These features are designed to simplify operations and improve the reliability for your MySQL workloads on Azure. Thank you for joining, and I'm happy to take questions or revisit any part of the demo.
Thank you, everyone, for watching this demo. Just a quick note that the customer port, some customer may not see it in portal. We are, actively deploy this change to our global regions, so you should be able to see it in very soon. Okay, Sarah, back to you.
All right. Thank you, Elendil. That was a great overview and a great demo covering various aspects of how you can enhance MySQL management. A quick recap for our audience that our September recap blog is available at this URL, aka.ms/MySQL-SEP 2025-recap. And a few of the updates that have just gone in over the last month include the updates that Elendil spoke about here as well. In terms of our documentation, here are some of the URLs where you can go and learn more about Azure Database for MySQL. And for any questions, queries, or assistance while deploying or managing Azure Database for MySQL, the email ID is mentioned on your screen. Ask Azure DB for MySQL at service.microsoft.com. So feel free to address us, and we'd be happy to answer any questions. Here are some of our social media channels, if you want to subscribe to them across YouTube, X, and LinkedIn. And we would love to get your feedback on the webinar that we've conducted. And if you want to share any topics that you want to see in this webinar series going forward, or just you want to collaborate with us on any aspects during our journey. And with that, thank you for tuning in today, and we hope to see you next time again. Thank you.